Okay, so this one we're going to learn how to solve the rest of the exercises. So look at our joints. You've got pin joint, so you're going to be CX and also CY. And definitely there are a few forces, 3 kilonewton, 4 kilonewton. Yeah, this is a cable that is we label as T as tension, right? So cable is there, and we have to resolve lah. So there are two components, T cos 30 degrees and also T sine 30 degrees. So there are two components lah for this T. So let's solve. Starting with summation fx is equal to 0. To the right is positive, right? This is our convention. And look at all the x components, cx minus t cos 30 degrees. And that's all lah. Is equal to 0. This is all the x components. So y components, there are a few more lah. Going up is positive. So you've got cy. And then you've got 3 kilonewton going down. And then you've got 4 kilonewton going down. And finally, you have one more, which is T sine 30 degrees. And it's going up, so it's a positive value, equals 0. So this is the equation of equilibrium for y. Next, we go for moment. So moment, we have to take a look at the location which is the most mystery. So paling banyak unknown is location C. Location C, dia ada CX. Lepas tu, dia ada CY. So dua benda tak tahu. Dua benda unknown. So ambil dekat C. So C is equal to 0. Summation of moment at C is equal to 0. Convention, counterclockwise is positive. So now let's put in all the values. So since C dekat tempat yang kita calculate, CX dengan CY tak masuk dalam calculation. So it's become very convenient for us lah. So this is the location that we are calculating our moment. So you are here at location C. So let's not get confused. This is where you are calculating your moment. So the first one, 3 kilonewton is going that way. It's clockwise. So it's a negative. 4 kilonewton, it's a negative again. Because it's rotating clockwise kan. So plug in. 3 kali distance 2. Tolak 4 kali distance dia adalah 4 juga. And then you've got two components lah. One is T cos 30 degrees. And you've got another component. T cos 30 degrees is actually rotating counterclockwise, so positive. T cos 30 degrees kali dengan distance. Distance is 2 meter. So, and next one is T sine 30 degrees. It's rotating counterclockwise, so it's a positive. So distance dia berapa? T sine 30 degrees kali dengan perpendicular. Okay. So this is the distance that you have to look for. The distance is actually up until the location yang kita ambil moment tadi tu, iaitu dekat C tadi tu. So 4 meter, kena letak 4. and equals 0. Summation of moment jadi 0. So sekarang kita boleh solve lah. So simplify a bit. Become negative 6, negative 16 plus, use your calculator, T 1.732 T plus 0.5 kali 4 dapat 2T. Betul ya? Punch in your calculator, yeah, 2T. So you can simplify the equation a bit. 732 equals, bring over to the other side, 16 plus 6, you get 22. And then you're going to get your answer lah. T is equivalent to 22 divided by 3.73. You're going to get 5.89. So the value you need is kilonewton. So next, you do the same procedure that we've been doing for so long. Plugins, right? So you got to plug in at our first equation. So plug in there, T 5.89 dapat CY. Plug in dekat first equation dapat CX. Patutnya dapatlah value ni, 4.05 dengan 5.11. Okay, so all is done. So it looks complicated a bit, but it's not really that complicated lah. Next equation. So let's look at this. Yeah, it's good to close it first, and then we can do it properly one by one. Okay, this is let's look at this one. Free body diagram is kind of given to you, but it's not always the case, right? So let's start. So when you're doing your free body diagram, you only have to consider external forces for equilibrium of rigid body. So even though you have all these internal force, internal beams, all these things, you don't really have to consider it yet. You just have to consider external. So dekat E kita ada roller kan. So roller dia punya direction, arah yang dia tak boleh bergerak tu adalah X. Yang dekat A kita ada pin. So pin lah. So put all your reaction forces. So pin kita ada dua, X and Y. And then at 4,000, and then put all your external forces. You got 500 Newton, which is, and then label lah, should label AY, and then finally this one, which is the 4,000. If you want to make your life easy, you can transfer it to the front. Transfer your force lah. Otherwise, you are okay already. But it's kind of good to transfer. Pull it down. So make sure your angles are correct. That is 30 degrees over there. So when you transfer the 30 degrees, you have to transfer it properly lah. 30 degrees is opposite of the angles. Now you can transfer. This is your 4,000 Newton. Right? And then once you have resolved into vertical component, kita dapat 4,000 cos 30 degrees. And then you've got 4,000 sine 30 degrees. So these are the two components involved. What else? I think that's it. Okay, let's look back at this problem. Okay, so let's solve. If you're confused, you can remove the components that is not involved in your calculation. You've done all your job, right? You have resolved properly. If you want to be less confused, you can remove it lah. Otherwise, just keep it. Okay, so let's do the equations that we are supposed to do. Summation fx is equal to 0. All the x component. Summation fy, all the y components. And finally, summation of moments. Definitely, we're looking at the location with the most unknown. Paling banyak benda tak tahu. Definitely ada dekat A. Counterclockwise is positive. So kita solve, no, my example is solving for you the moments dekat A je lah. A, remember you're doing it at A, location A. So EX kita akan dapat positif macam tangan kanan. Counterclockwise. 500 Newton also positive. 400 sin 30. Dia betul-betul masuk dekat A. Dia tidak ada distance. There is no perpendicular distance. 90 degrees, remember? So there is no perpendicular distance. So kalau kali dengan 0, dia akan jadi nothing. 400 cos 30 degrees, dia akan jadi negatif. Sebab dia clockwise. 4,000 sin 30 ni tak ada. So now, let's put in properly in our equation. So, starting with EX, distance perpendicular 3. Okay. And then, 500 Newton. Distance dia adalah 8 meter. All the way from origin sampai dekat 500 Newton tu. Perpendicular distance dekat A kan. So, from location A is actually 8 meter. Next, apa lagi? Minus 4,000 cos 30 tu, dia adalah clockwise. So, minus 4,000 cos 30 degrees kali dengan distance dia adalah, okay, you guessed it right, 4 meter. Equals 0. So if you solve this properly, you're going to get the value of EX lah, berapa? So once you get the EX, plug in the formula of summation fx, plug in dekat formula summation fy, okay? Then dapatlah value dia berapa? All those unknowns. Dapat berapa AX, dapat berapa AY. You're going to get all the values lah. Okay, for a roller, you have to remember one reaction force. Bukan two. Pin yang duanya tu. Dekat pin ada 2 unknown. Okay, you can pause and do it on your own lah. So this is the next problem. You have fixed location A kan. Location A dia fixed. kita ada dua unknown lah, satu AX, satu AY. And then you have moment dekat A. Berapa moment, berapa AX, berapa AY. And then you've got this 400 Newton, you have all these forces from all these loads. So you need to pakai I-beam tu, nampak? I-beam. So 400 you can resolve into components which is horizontal dia 400 cos 30 degrees. Vertical dia 400 sin lah. Apa lagi? Sin 30 degrees. And then you've got moment komponen 200 ni jadi negatif. 200 pun sama juga negatif. And then 400 sin 30 pun ada. 200 ke atas pun negatif juga. Ini pun negatif juga. How about last one? 400 cos 30 negatif ke positif. So it's actually rotating clockwise. You guessed it right. So it's a negative. Semuanya negatif. Berapa komponen ada? 1, 2, 3, 4 yang bawah ni. 5. So ada 5 benda kena cari dia punya moments. Kali dengan all the distances. But solve it properly lah. Summation Fy, summation Fx, and summation moment dekat location A lah kan. Apa lagi? Location A. And then you can solve it properly all. Okay. Alright. Right now you have to pause and then solve on your own. Okay. Do on your own. Pause the video. Take your time. So this is the next exercise. Let's do this properly. Even though you have the solution, I know. Let's solve this properly. So look at this structure. It looks kind of complicated, but it shouldn't be. You've got pin. So, and then you've got location B, roller. Roller boleh bergerak kanan kiri. Tak boleh turun bawah. So, reaction force kat bawah. Okay. Let's draw a free body diagram. Draw dia punya external. Okay. Draw dia punya external saja. Tak perlu draw dia punya internal punya members pun tak payah. Draw dia punya external. Okay. Let's draw properly. Like this. And then like that. And then label all your forces. So the internal parts tak payah lukis pun. No need to draw your internal structure. Now, put your reaction forces, pin joint, dua benda. X and Y. Label it. And then you've got this external force which is 5 kilonewton. And then you've got 10 kilonewton going down. And finally at the roller you've got 1, which is By. 10 kilonewton kat setengah tu kan. And then 5 kilonewton. And then of course at your pin joint you can label it AY, AX. But yeah, you have to consider lah the angle tu 45 degrees tu. How do you resolve dekat 5 kilonewton? Macam mana nak resolve? Okay, got it. So 45 resolve into X and Y. So 45 degrees, draw it properly. 5 cos 45, 5 sin 45. Okay, so the rest are you can do it on your own lah. Follow the same procedure lah. So pause, like the fish pause, ikan paus. Okay. So pause. Okay, this one same like in your tutorial 534. You can look in your tutorial how to solve. This one is a pin joint, and then you've got some sort of slot. So arah mana dia tak boleh gerak. You've got some contact at location B. Dia ada macam satu pin kan. So at that location lah. And then 600 ni kena resolve lah. X and Y kan. You can solve it. And then the last one. You've got, what is this? What is this? Pin joint. This one, roller. So you've got 10 kilonewton, you've got 6 kilonewton. How do you resolve that 6 kilonewton? X component, Y component. Macam mana nak buat tu 60 degrees tu? 60 degrees is like that. And then kalau 90, sini 30 kan? 30 degrees. So both components. 6 kilonewton dekat tengah. Ini 6 cos 30 degrees. Definitely the other one is 6 sin 30 degrees. Okay. The rest is in 3D. You can solve this one, right? So do your tutorials. A lot of things that we have done, a lot of things that we have covered. Solve it on your own. So you can use all these calculations in your final year projects. There are a lot of examples, structures that you have to design and you have to do for your experimental rigs. So all these forces, consider them. All these are equilibrium of rigid body. Definitely we want to see all these in your final year projects. What have you done? How do you put it to good use? And for 3D also, method is almost the same. Only thing is you have extra axis. So for example, here, so you've got moments in X, moment in Z. So there ada dua axis lah kena solve. This is the free body diagram for 3D. If you look at it, you've got a roller, satu juga, ball and socket ada 3, X, Y, Z. Bearing. So for bearing, ada berapa tu kat bawah? Atas ni walaupun 3D, dia still 2D. Ini, ya, 2D. Ini 3D, no choice. Ini 2D ke 3D? Not 2D, right? You have two moments. Moment X, moment Z. So still 3D. This one is 3D. This support structure is 3D. How about, yeah, this is one example that you can do lah on your own for 3D. So you can try to solve on your own. Okay, so apparently that's it. So see you guys in the later lectures lah. Alright, studying. Bye bye.